Hello, this is Mrs. Poland, and this is for Common Core Algebra 2, Unit 1, and this is the Delta Math homework for the grouping lesson. So I'd like to go over some of the hardest skills. The first one is binomial as a GCF level 2. For this problem, I noticed with both these two terms that there is a common binomial of 2x minus 3. The first one, it's raised to the fourth power, and the second one is raised to the third power. That means that the GCF is 2x minus 3 raised to the third power, since they are 3 in common. I'm going to divide each one of these terms by that GCF. For the first term, I keep the base and subtract the exponent, and I'm just left with 2x minus 3 raised to the first, which is just 2x minus 3. For the second one, since they both have the same exponent, it reduces to 1, and I'm left with minus 8. I combine like terms on the inside of the parentheses. Negative 8 minus 3 is equal to 11. So this should be my final answer. I'm just going to clean this up. That's why you should use pencil. The next skill, I want to factor by grouping 6 terms. Either break it into 2 groups of 3 or 3 groups of 2. And you always do the easiest first, which is to break it into 3 groups of 2. So I notice x squared is in common with the first group, and the balance is x squared minus 4. For the second group, I know 11 is in common as well as x, but also you never want to have a negative leading coefficient, so we're going to factor out a negative 11x. 11x cubed divided by a negative 11x is simply x squared. 44 divided by negative 11 is negative 4. And now let's go to the last term. What's in common to 24 and 96? Well, I know that 24 times 4 is equal to 96, so I can actually factor out that positive 24. I notice that I have a GCF of x squared minus 4, so I'm going to factor that out. And I'm left with x squared minus 11x plus 24. So now you want to factor each of these terms further. So x squared minus 4, I can apply dots and factor it into x plus 2 times x minus 2. For the trinomial, I see a plus before the last term, indicating the signs are the same. And since there's a negative between there, both signs are negative. I'm looking for 2 factors of 24 that add to negative 11. So we have 6 and 4, 4 and 6, 2 and 12, 12 and 2, 8 and 3, 3 and 8, 1 and 24, and 24 and 1. And the ones that add to 8 are 3 and 8, or 8 and 3. It's really the same. And this is your final answer. The last problem that we're going to do is also factor by grouping of 6 terms, but in this case, instead of pairing by 2's, we're going to pair by 3's. And the reason for it, you don't have to write this down, is that here, I can factor out an x squared and get x plus 2. But if I try to do something with the second one, like maybe factor out a negative x squared, I'm not going to get that same situation. I can combine this, it's not going to work. So we know that's not the way to go. So if it doesn't work when you try to pair up in 2's, try pairing by 3's. So with the first group of 3's, or the triplets, I'm going to factor out an x squared. And if I divide each term by x squared, I get x squared plus 2x minus 3, because negative 3x squared divided by x squared is negative 3. For the second grouping, again, you never want to have a negative leading coefficient, so I'm going to factor it out. But I know that 25 is a factor of 25, 50, and 75, so I'm going to factor that out. And when I do that, I get x squared, negative 25x squared divided by negative 25 is x squared. Negative 50 divided by negative 25 is positive 2x. And finally, 75 divided by negative 25 is negative 3. I now have a common polynomial or trinomial of x squared plus 2x minus 3. And when I factor that out, I'm left with x squared minus 25. I can factor each of these pieces further. So the sign's going to be different in the parentheses for the trinomial. Two factors that multiply out to negative 3 and add to positive 2 are 3 and 1. For the second polynomial, I can apply dots, and I get x plus 5, x minus 5. And there you have it. Have a great evening.